All right, welcome back, eighth graders. We're going to get into equations with special cases. What that means is we're looking at whether we are going to have one solution, no solution, or an infinite number of solutions. So I started off with two different equations. We're going to look at those two, and then if I have space, I'm going to try and squeeze that third one in there. So we're going to try and solve for x. Anytime you have an equation where you need to determine whether there is going to be only one solution, that means only one answer can fit your x, or there's no solution, which means you'll never get an answer, or there's going to be an infinite number of solutions. That will be for x. So we're always looking for what is x. What is x going to be? So let's get started. I'm going to look at this as a two-step equation because I don't need to distribute anything. I don't need to combine anything. I don't have variables on both sides. I just need to determine what is my x. So this is just a straight two-step equation. So we're going to subtract 12 from both sides. And I'm going to bring down what I did not use. 21 minus 12 is going to give me what? If you don't remember, do your regrouping. If I put a 1 here, and this crosses out, and that becomes a 1, then I have 11 minus 2, which would give me 9, and then 1 minus 1, which is 0. Okay? Last step, divide both sides by 3, x equals 3. What this means is we only have one solution for this problem. We are not going to have more than one solution for this particular problem. While I'm here, I'm going to go ahead and put the last problem down here because I want us to be able to see all of them. So moving up here, I have variables on both sides and I have constants on both sides. So that means I'm going to need to go back to what we talked about in the first video when we looked at variables on both sides. How do I solve variables on both sides? Well, you're going to move the variable first. Because both of them are the same, it does not matter which one you move. So we'll just move this one. So we'll say 5x minus 5x. That happens to cancel. And then that actually happens to cancel. So then I'm going to bring down what I didn't use. Now I'm going to show you what we have here. I brought those two down. However, does this equal this? Does 1 equal 3? That's something to think about. We'll get back to that in a second. Let me move this up a little bit. We're going to look at the last one. And then we're going to determine what category each one will fall under. All right, same thing. I have variables on both sides. I'm going to go ahead and do 8x. I'm going to subtract 8x from both sides. And I'm left with negative 2. See, there's a subtraction sign, which means anything after it is a negative. And then I just bring down what I didn't use. We brought down what we did not use. Bring this down. And bring this down. Now we need to determine 1, none, or infinite. That's my little infinite sign right there. Boop, infinite. That's what that means. I just made that up. So it's going to be infinite. Okay? So which one is this? Is it 1? Is it none? I'll write the word none because I'm saying none. 1, none, or infinite. Let's take a look. How many solutions do I have for this? X equals 3. What that means is x can only equal 3. So this is only going to have one solution. One solution. It cannot have any more solutions. It cannot be x equals 2, x equals 7. No other solution will make this equation true. The only solution that will make this equation true is for x to equal 3. That's the only way to make this true. Let's look over here. 1 equals 3. Now, on any planet that you might travel on at some point, in your brain or just any kind of way, okay? 1 will never equal 3. It can never equal 3. So when we show that something can never equal, that's what we do. So what that means is 1 cannot equal 3, which means, do we have any solution? Will we ever have a solution for this problem? No, we will not. So this is a no solution. That's a no solution. That's a no ma'am. That's a no ma'am. Okay? That is a no solution. What about this one? Let me block these things off because I want to make sure you're not getting confused about what's what. That goes to that one. There we go. Now we got some separation here. So down here, we have a -2 equaling a -2. Well, is that true? Can a -2 equal a -2? It absolutely can equal a -2. -2 is always going to equal -2. What they're saying is, no matter what number you put in for x, no matter what number you put in for x, this will always be true. So if x is 3, it's going to be 3 on this side and 3 on that side. It's always going to be true. As opposed to up here, if you put a 3 in for x and a 3 in for x, you're still never going to have the number on the left equaling the number on the right. Down here, any number you put in for x, any number you substitute for x, any value you give to x, however you want to say it, you are always going to have your answer on the right, on the left equal your answer on the right. Therefore, you have infinite solutions. Not easy to write with this big marker and E. It just does not want to, doesn't want to work with me here. Doesn't want to work with me. Okay? So hopefully that was a reminder to you because we did that. Remember, we played the 4 corners 3. Y'all remember that? We did 4 corners 3 in the room and we running around like crazy people. Because I said, tell me whether it's one solution, no solution, or infinite solutions. Because we talked about how can I tell? I can tell because if this number, if my variable and this is the same, and my coefficient of my variable is the same, but my constants are different, no solution. You only have to do the work. You only have to you look at it. Like, oh, I can look at that and see. That's not gonna work. That's not gonna work. If these are the same, sorry guys. If these are the same, but these are different, not gonna work. So you can look at it and say, nope, that's never gonna work. Over here, if these are the same and these are the same, it's always gonna work. No matter what number you put in there, it's always gonna work. So when we played 4 corners 3, and everybody had to run to the corner that had one solution, no solution, or infinite solutions, depending on what equation I gave you, that should be a reminder. Oh, I remember when we did that because I was too cool to run. Or I actually knew what I was doing and I was getting them right. Or I saw the people who were getting them right and I ran with them and then we discussed it so that it actually made sense to me after I ran and followed somebody else, which is okay. You were engaged. That's all I care about because now you remember and you can bring back that recall and say, oh yeah, I remember we talked about that. I remember how to identify whether something has no solution or an infinite number of solutions just by looking at it. Okay? So I'm gonna do one more video and we're gonna discuss how to analyze and interpret a graph. So I'll see you in the next one, guys.